Hello there my friends, welcome back to this channel of sciencing around, and I'm here to explain you another topic of the physics, which is called as the simple harmonic motion. Today I'm not gonna go quite harsh because I want to go quite slow as I have a throat infection. So let's get on with the simple harmonic motion, guys. What the hell is simple harmonic motion? Now let me take my pen and let me take a page. Suppose this is a point. Then what the hell is simple harmonic motion? This is the simple harmonic motion, guys. This is increased acceleration, simple harmonic motion. Increased acceleration and much more. Oh my god, my page. So I hope you know what is simple harmonic motion. The first equation of simple harmonic motion tells us that force is directly proportional to the displacement, where x is the displacement. Force is directly proportional to the displacement. That means force equals minus of kx, where k is constant, and therefore we can say that k equals to minus of f upon x. The value of k. What the fuck did I write? Acceleration equals f by m. I know that equals to minus of kx by n. Okay, that's good. Acceleration equals minus of kx upon n. Also, acceleration equals to omega square x, where omega value is under root of k by m. Acceleration of simple harmonic motion is this thing, where x is the displacement of the simple harmonic motion, and the relation between the force and displacement is right here. You can see in the graph. Slope is minus k. Since force is directly proportional to displacement, its slope is minus k. So d square x upon dt square, that is acceleration, equals minus of omega square x. So fuck these two formulas, they are the same, they are the bloody same. Please subscribe my video. Sufficient equation to be in SHM is force is directly proportional to the Force is directly proportional to the negative of displacement, where k is a positive constant. So acceleration is directly proportional to negative x, since force equals mass into acceleration, whereas mass is bloody constant. Now let's get on to general solution. General solution, a fucking thing which we have to learn, of course, where x equals a sine of omega t plus or minus phi, where phi is the phase angle. Of course, you know what is omega. X is displacement, a is amplitude. Now amplitude is this thing, this distance is the amplitude. I hope you know. X is displacement. Now x is equals to a sine of omega t, then velocity equals omega a cos omega t, and acceleration equals minus of omega square a sine omega t in any oscillation, we can say. And another shitty equation for velocity equals omega root of a square minus x square. Actually, velocity equals omega a, but for distance x, velocity equals omega root of a square minus x square. That's the fact. This page is over. Let's get up to the next page. Acceleration. Let me get a simple harmonic motion on this fucking formula. I wrote this formula right here somewhere. Where? Oh yeah, here. Where the fuck did I write it? Come on. So acceleration equals omega square x. I hope this thing is sufficient. And here I wrote it. And now let's get on to our next thing, that is energy. Potential energy equals to u naught plus half of kx square, where u naught equals velocity, initial velocity. Total energy equals u naught plus half of ka square, and kinetic energy equals half of k times a square minus x square. So half of k square, That means total energy equals half of m omega square a square, that equals to energy. Yes. Now let me tell you the graphical representation of the kinetic energy and the potential energy. I'm sorry, I'm not good at drawing lines. That doesn't matter to me either. It varies like this. This is the mean position. This is the mean position, and this is the orientation of kinetic energy. Guess what is kinetic energy? Of course, at the mean position, the kinetic energy would be maximum. So this is kinetic energy, and this is potential energy. Yes. Now, another badass thing we have to learn is speed at mean position is omega a, at extreme position is 0 since it comes to rest, and any general equation for speed is this. Acceleration at mean position is of course 0, and extreme position plus or minus omega square a, and general equation minus of omega square x. Kinetic energy half of m omega square a square, and at extreme position of course it is 0. And so half of k times a square minus x square is the kinetic energy. And for force, mean position is 0, or at mean position force is 0. At extreme position force is plus or minus Ka, and any general point force is minus of Kx. As we told in the back page, force is directly proportional to negative displacement since this, any general point. Potential energy is U0, and at extreme position is half of Ka square, and any general position half of Kx square. Total energy, potential energy plus kinetic energy, potential energy plus half K square at extreme position, and at any general point U0 plus half of K square. Now we have something to study again, that is the spring block system. Omega root of K by M. Omega equals under root of K by M. I wrote it again. Very useful formula, very easy to learn, and with a very high weightage I observed in many of the exams. Time equals to 2 pi upon omega, or 2 pi under root of m by k. Since omega is under root of k by m, time equals 2 pi under root of m by k. Frequency is 1 upon time, so just reciprocate this fucking thing, you get this shit. Piece of shit. So mass attached in weighted spring, hanging spring, or horizontal spring. Then time equals to 2 pi root of m by k. Why the heck did I write it again? Come on, let's get on. Now, if the spring is in series, that means if this is a spring, just believe it's a spring, another spring. They are in series with the constants as k1 and k2. Then, in spring in series, then 1 upon k effective equals 1 upon k1 plus 1 upon k2. And if springs are connected in parallel, simple as that. Resistance, opposite of the resistance connection is the spring connection. Actually there's no relation, just for your sake of understanding I'm telling this whole thing. Otherwise this parallel, yeah. In case of two masses attached to one spring, yeah, you can visualize there is a mass m1, and there is the mass m2. There is a spring inside, and two masses are attached at its other ends. The time equals to 2 pi root of nu by k, where nu is equal to reduced mass, and reduced mass is simply m1 m2 upon m1 plus m2. That is 1 upon m mass reduced equals to 1 upon m1 plus 1 upon m2. This shit. Also, every wire is like a spring. I know this thing. Come on, man. I know every wire is like a spring. Yeah. Why is the Young's modulus, my guys? I hope you know what is Young's modulus. If not, I'll make another video. Don't worry, I'm gonna make it. So that time the K, or the spring constant of the wire, equals to Young's modulus into its area upon its length, that is YA upon L. As simple as that. And many times I heard in many of the questions or many of the question papers, this type of format comes. This question, the question based on this, that is, if a plank or if anything mass m is floating in water it's something is behind something, some part is below the water surface, some part is above the water surface, then it is a simple harmonic motion. Rho is the actual density of fluid, and if plank of mass m is floating in water vertically, it acts as the spring and density of water is rho. Then the constant, then this thing acts as the spring whose constant is rho ag, and mostly they ask us the time period for this. The time period is 2 pi root of m upon k, so 2 pi root of m upon rho ag. Yes, it's rho ag, 2 pi root of m upon rho ag. And god damn it, you have to learn this thing again. If mass of spring is also given, that means if the mass of spring is given, then what is time? Time is actually 2 pi root of m by k, but here time equals 2 pi root of m plus mass of spring divided by 3. I don't know why did they divide this by 3. I didn't see the derivation actually anywhere in the books where I read. So time equals to 2 pi root of m plus mass of spring divided by 3 upon k. Simple form of t equals to 2 pi root of m by k. Now let's get on to pendulum. What the fuck is pendulum? Come on. Only small oscillations are SHM. That means the oscillations of a very small angle, probably d theta. Yes, very small angles. Time equals 2 pi root of L by G. We had time equals 2 pi root of M by K. It's time equals 2 pi root of L by G, where L is the length of pendulum. That means if here is a ball, then this is the length. Time equals 2 pi root of L by G for pendulum of infinite length. That means if we have been given a pendulum whose length is absolutely infinity, we can't measure its length, then simply we give up by saying that t equals 2 pi root of L upon G E bar. Yes, where G E equals to G bar minus A bar, or G bar plus of minus A bar, that is the acceleration of the other pendulum. Yep, the acceleration vector which is given. And time equals 2 pi root of L upon G plus A. Yep, L upon G, so L upon G plus A, because the total acceleration is this thing. And if the constant force acts on a pendulum, we can say damping force or something, then time equals 2 pi root of L upon G plus F by M. Since it is G plus A is simply motherfucking F by M. Acceleration equals force of mass. Come on, F is equals to ma. So time equals 2 pi root of L upon G plus F bar upon M. And the last shitty thing, quite asshole, I didn't understand it much, but in any physical pendulum, what is physical pendulum? I know if we have been given any uneven body, if we fix its center and take the length from this, then it will oscillate. Sorry, if we fix this thing, then this will oscillate at very small angles. Oscillate very at small angles. Then if its moment of inertia is I hope I didn't make any video about rotational motion. I'll make it soon about the moment of inertia and other shitty things, but for now this simple. If they have been given us the moment of inertia of this particle, then time equals 2 pi root of moment of inertia, that is I upon mgl. That's it. And in any SHM, the average kinetic, why did I write this again? Come on, half m omega square a square, or half omega fuck you again. The kinetic energy in any SHM equals half of m omega square a square cos square omega. Sorry again. Kinetic energy equals half of m omega square a square cos square omega t plus or minus phi. So let me write it again. Kinetic energy equals half of m omega square a square cos square omega t plus phi. Phi is the phase angle. I hope this much is okay for today. We have completed our notes, and I've just covered up each and every difficult, or I must say most weighted topic in the exam of the simple harmonic motion. In the next video, I don't know what would I do, but I would do something very useful. I hope this video was useful, and if you think this video was useful, please like and subscribe this video. And don't subscribe the video, so of course subscribe the channel and like this video, and please leave the comments on how should I improve myself, how should I do myself to get more views for you, how should I earn your subscription. Alright, so thank you guys, happy sciencing around, goodbye, see you soon.